Thank you very much. Whoa. Thank you very much. That's very kind. I appreciate the privilege and honor of being here today, and thank you all for the opportunity. As Myra said, I spent 3 decades of my career working as a professor at Cornell University, mostly with dairy cows, although on many other animals, and then 15 months ago moved to Ross University in St. Kitts, where there is not a single dairy cow. I had an opportunity to exercise my passion for the ocean and wanted to share with you a topic on which I'm no expert, but which I feel is really important for every one of us. Despite the fact that Aristotle, in his early attempt to impose some order on the universe of living things, classified corals as plants, there is now no doubt at all that they are animals. That is universally accepted, and therefore they are a legitimate target of veterinary attention. And so I wish to make the case for them today. My first introduction to corals was a trip to the Great Barrier Reef in 1992. And like most people, I imagine I was spellbound by the immense beauty of corals and the entire coral reef ecosystem. In the intervening years, I heard, like everybody, about erosion of the health and presence and persistence of corals, and I tended to think of that in exactly the same kind of way as the same process that's happening with terrestrial mammals, where we hear of endangered and even extinction of some species. And those events are tragic losses of things of great beauty that are irreplaceable, and I thought of corals in much the same way. And of course, that's true, that it is a deeply regrettable, irreplaceable loss of a thing of beauty. But in the case of corals, I want to make the point that it is, in fact, much, much more. So corals are animals that live in vast colonies. They consist of a multitude of little animals, little polyps, and each polyp has quite a simple structure. It lives inside its little calcium carbonate exoskeleton in a little cup, and the polyp itself, it's like a little tin can, and it has a mouth that serves as an anus also, and the mouth is surrounded by some tentacles which have nematocysts. These are little stinging cells that can shoot out and actually catch prey, catch little fish in some cases, and it helps the individual polyp catch food. But the corals have another source of nutrition, and that is the zooxanthellae. These are single-celled photosynthetic algae that live in the flesh of the corals. And they play a critical role. They also impart the color to many corals. And the important part of them for the shallow water corals is that they are photosynthetically active. This is critical because most corals actually grow in quite nutrient-poor water. So they grow in water that's low in nitrogen and phosphorus and calcium and other nutrients, but they manage to support this massive ecosystem, and part of the success for doing that is having these photosynthetic algae that can capture the sunlight in this clear and sunny water. So the corals then are not only beautiful, they have enormous value to mankind. They occupy less than 1% of the ocean floor, but they support over 4,000 species of marine animals. So probably more than a quarter or 40% of ocean life depends to some extent on the association with corals. They nurture the young of commercially important fish. So in that role, they probably support the pelagic fisheries, which would collapse without them. They support about 500 million people who depend directly on the fish they take from coral reef areas directly. In fact, in developing countries, about 20% of the total fish catch comes from direct coral local fishing. And as I said, they support the pelagic fisheries as well. Other income comes from tourism, recreation, education, research, whose income supports the local and national economies of countries with coral reefs. And in that way, that multiplying effect means that corals directly and indirectly affect the livelihood of some 2 billion people. So a good chunk of the world's population. They also provide physical protection for the coastline. They protect against erosion, they protect coastal communities, they protect the infrastructure, they preserve mangroves, and they preserve the seagrass beds, which are important also for other forms of sea life. Now, recently we've heard a great deal about coral damage, and in the Caribbean, in the last 30 years, about 50% of the corals have been lost completely. And many of us will be aware that in the last 2 years alone, the big bleaching episodes of the Great Barrier Reef have affected 2/3 of the Great Barrier Reef in just the last 2 years. Now, bleaching is not death of the coral. Bleaching is brought about by many adverse environmental conditions, most notably increased environmental temperature, and this affects the relationship between the polyp and the zooxanthellae, those little photosynthetic algae. And the algae are either killed or expelled, and without the algae, the flesh of the coral is actually transparent. So you look through the live coral flesh and see the exoskeleton, which is white, and that gives the bleached appearance to the coral. And if the conditions are restored to favorable ones, the coral can replenish the zooxanthellae and survive. But prolonged bleaching does lead to death. But importantly, a great contributor to the death of the corals around the world is actually infectious disease. And it is this that we know perilously little about. There are only 5 diseases that are generally regarded as having fulfilled Koch's postulates with regard to corals, and even those are somewhat in dispute. When you hear the names of coral diseases, they remind me of the situation that we were in 200 years ago with domestic animal diseases. The diseases of corals that are known or regarded as having fulfilled Koch's postulates are known as white plague, white band, white patch disease, aspergillosis, and bacterial bleaching. Other diseases are red band, yellow band, and brown band. There is Caribbean white disease, and there are galls. So we know very, very little, and I think because our knowledge base is so small, our ability to understand the prevention or treatment or cure of these diseases is also almost non-existent. The studies, such as they are, of coral disease are mostly wide-scale observational surveys with very little detailed examination of what's happening at a cellular level to sick corals. Less than 10% of publications on diseases of corals include any kind of histopathology or record of damage at a cellular level. And it is here that I think that the veterinary profession has enormous contributions to make. The coral is in many ways comparable to an epithelial surface, so the kinds of things that veterinary pathologists are familiar with in terms of pathogenesis at skin surface and gut surfaces are not unlike the disease processes in corals. I think that histopathology in particular will allow a better understanding of the interaction between tissue and pathogen at its interface, and give us some insight into the tissue reaction to those pathogens, and allow a much more solid understanding of the relationship between potential pathogens and the disease that they are suspected to cause. I think without a deeper understanding of this, we're doomed to just watch corals disappear. In addition, samples for histopathology are easily collected without many resources, without refrigeration, and those preserved samples can be processed via other technologies to provide information about these diseases. Corals reproduce sexually as well as asexually, and the fact that they have a sexual reproduction component means that some selection is possible. And this has been exploited recently and may be a promising avenue. So, for example, corals that have survived bleaching, which by virtue of the fact they survived are assumed to be heat tolerant, have been cultivated in laboratories with the aim of releasing them again to repopulate corals with heat tolerant strains. In another experiment, corals that have survived bleaching in the warmer northern parts of the Great Barrier Reef have been translocated to the south, where it's a little bit cooler but getting warmer, in the hope that they will crossbreed with the local southern corals and produce heat-tolerant strains which will be more resilient to future warming in those regions of the reef. But even though there is some promise related to the intensive cultivation in laboratory circumstances of corals, we all know as veterinarians that whenever we intensify agriculture of animal species, we also increase the incidence of disease. And so veterinary involvement in these activities, I think, is also beneficial and potentially even critical. What I hope I can leave you with is the concept that no matter how far you live from the ocean, your life and well-being are directly or indirectly affected by the health and continued well-being of the corals of the world. And also that we as a profession have a role to play in the continued health and well-being of these incredibly important and incredibly beautiful custodians of biodiversity in the oceans. So thank you very much for your time and your attention. Thank you.